Today, we're diving into one of the most brutal and honestly one of the most fascinating survival strategies on the planet. We're talking about the emerald jewel wasp, a tiny insect that turns a much, much larger cockroach into a living, walking nursery for its young. Yeah, it gets weird. And this whole unbelievable story really hinges on one central question. How on earth does a wasp perform what is, for all intents and purposes, precision brain surgery with nothing but its stinger? So, to really get what's happening, we first need to understand the state the cockroach enters. It's called hypokinesia. And this is key. It's not paralysis. Not at all. The cockroach can still move. It can walk, it can swim, it can even fly if you push it. But it has completely lost its will to escape. It's become a totally compliant puppet. So how does the wasp pull this off? Well, it all starts with an incredibly precise, almost surgical physical attack. It's a two-step procedure, and it's perfect. First, there's a quick sting to the body. This causes a temporary paralysis in the front legs, just for a couple of minutes. It basically just holds the roach still. But the second sting, that's the masterstroke. It's a meticulously aimed injection straight into the cockroach's head, targeting specific parts of the brain to take over the controls. But you have to remember, the stinger itself is just the delivery system. It's just the needle. The real weapon here is the venom. It's this complex chemical cocktail that wages all-out war on the cockroach's nervous system. And the venom's strategy is absolutely brilliant. It doesn't just block one little thing. No, it unleashes what scientists call a storm of its own neurochemicals, just completely overwhelming the host's brain and hijacking the whole system. I mean, just look at this stuff. The venom is a multi-pronged weapon. It's got neurotransmitters like dopamine to trigger weird behaviors. It has paralytic agents like GABA for that first sting. It even has spreading factors that literally break down tissue so the venom can get where it needs to go. And most fascinating of all, it has these sleeper agents that only wake up and become active later on. Let's just focus on dopamine for a second, because this part is pure genius. Right after the brain sting, the dopamine surge makes the cockroach groom itself, compulsively, for about 25 minutes. It's a bizarre sight. But here's the trick. While the roach is busy cleaning itself, that very same dopamine signal is quietly setting the stage for the long-term zombie state. It's an incredible bit of chemical misdirection. And this leads us to maybe the most ingenious part of the whole strategy. How does the wasp keep the roach in this state for a whole week? Well, the answer is that the venom is designed to be a time-release neurotoxin. You see, the wasp doesn't inject its most powerful toxins in their final active form. No, they're delivered as these inactive precursors. Think of them like little chemical sleeper agents, just waiting for the right signal to activate. So what's the signal? What wakes them up? It's just a simple change in pH. Inside the wasp's body, it's acidic, which keeps these powerful peptides stable and turned off. But as soon as they're injected into the cockroach's brain where the environment is neutral, enzymes in the venom itself flip the switch. The attack literally begins from within. This clever pH trigger creates a slow, continuous release of toxins. And what does that do? It keeps the cockroach in that compliant zombie state for 5 to 7 days, which, not by coincidence, is the exact amount of time the wasp larva needs to hatch, eat its host, and grow. It's terrifyingly perfect. Okay, so this whole brutal process is way more than just a horror story from the insect world. It actually reveals a really startling ancient connection between the brains of insects and, well, our own brains. This connection is explained by a concept called deep homology. It's the idea that wildly different-looking structures in different species, say part of an insect brain and part of a human brain, can actually come from the same ancient genetic toolkit. It suggests they share a common evolutionary origin for what they do. And here it is, the mind-blowing part. That region the wasp targets in the cockroach brain, it's the deep homologue, the ancient evolutionary cousin, to a part of our brain called the basal ganglia. That's the part that helps control our movement, our motivation, and helps us decide what actions to take.
By studying this wasp, we are literally getting a window into the fundamental wiring of our own will to act.
It really makes you wonder, doesn't it? The wasp has been performing precision neuromodification for millions of years, without any advanced degrees. It just leaves us with this question. What other profound secrets about our own brains are just waiting out there to be unlocked by nature's tiny neuroscientists?